intersections, we'll explore ways these disciplines can help us create a healthy and sustainable shared global ocean for ourselves and future generations. To talk about this, please welcome via Zoom Ted Janulis, founder and principal of Investable Oceans.
Good morning, good afternoon, good evening, wherever you are. I'm hopeful that you can hear me. I'm delighted to be with you. My good friend Emmanuel Goncalves had asked me if I could speak for 30 minutes on oceans and pull together exploration, science, technology, past, present, and future. And I said, sure, no problem. That's not difficult. Aside, I am appreciative of Emmanuel inviting me in because I think he's right on. I think all those disciplines come together. And I also thank the conference organizers for letting me participate with you today. About a unifying theme to take us through this because there are many elements to it. I've chosen maps, and I'm going to show you some maps that are older. I'm going to show you some maps that are newer, including some very high-tech maps. And my hope is that in addition to covering the theme that we've discussed, I'll also point you towards resources that are pretty exciting. So you'll leave with something to do. Go to really cool places, really cool things. So the title projects a little bit of what we're going to talk about. This, of course, is one of the older maps, the on the edge exploration, pushing things back, the great unknown, the monsters in the sea and then around us. That's a very primal thought that goes way back. But let's start with a slightly different map. There we go. So this is our planet, and it's a map. It's a map taken and made by astronauts from a distance from the Earth. It shows a black border and clear definitions, as geography does. It also shows that we have different kinds of land masses. We have a complex ecosystem with white and blue being our climate and our oceans. And it also shows that there's a lot of ocean there. So if you rotate that map, you can see that 71% of the Earth is covered by water that you always hear about. Here's a way to visualize that if you aim your camera into the Pacific Ocean, basically all you will see is blue. Now, humans have known that for a long time and have explored. And of course, speaking as I am to folks in Portugal, whether it's Magellan or other European noted explorers or Cook, there was a lot of activity in the Pacific Ocean in all kinds of ways and all kinds of reasons. So I decided to go a little bit further back. This is thousands of years back with the Polynesians, who are clearly among the greatest explorers, and all the colonization and pushing out that they did into different parts of the Pacific Ocean, with Hawaii, etc. So again, a lot of water here. But let's take a different view. Let's see if this clicks. This is a popular representation these days of a map that takes all the water on the Earth, all the salt water. Oops, sorry, I think we went one too far. It takes all the salt water on the Earth and makes it into that big droplet that you see. Interestingly, that tiny droplet that you see in the middle of America there is representative of fresh water, which is something like 2.5% of our water total on the planet. And of that, probably 3/4 or 2/3 of that is locked up in ice. So it gives you a sense. On the one hand, we've got this huge ocean planet. On the other hand, it's a very fragile layer that surrounds this very big block of what we call Earth. And so that's why we're so focused on preserving that, enhancing it, conserving it, being good stewards of it, being responsible in terms of how we harvest its treasures. So you can see there that this drains the water out of the Earth. Let's take another view of that. And this is a famous map. I want to make sure the clicker goes. Nope, I think I went one too many. I think there's a little bit of a delay. There we go. So Maria Tharp, 1953, Columbia University, makes a startling discovery. There are people all over funded by the Navy, which is not unusual. You'll see that as a theme throughout, is governmental funding, the intersection between commerce, military, and science. But they were basically doing all kinds of soundings to see how deep different parts of the ocean was. And what Maria Tharp was doing is back in New York, she was taking all those soundings and using complex equations to pull them together and devise topography. And in the course of that, she actually was the first person to really identify the Mid Atlantic Ridge, which is that huge crevice you see coming through in between Americas and Europe, if you will, but extending all the way down. And no one knew this at the time. So the first time it was actually perceived was through maps, but also science, but also exploration, all pulling this together with someone sitting in a room and pulling all these things together. It took a while for people to buy into that, but basically that was where the continental shelves were spreading, and that became a huge factor in demonstrating that there was in fact continental drift. Huge discovery. So let's keep going on that theme of going deep. Since we got all the water drained out, let's go to the bottom of the ocean and let's track the trajectory of how people explored that. So let's start in 1875 with the HMS Challenger, which, not unsurprisingly, was a military Navy ship that was converted for observational use. And they went on a 3-year circumnavigation of the globe. They discovered almost 5,000 new species, spotted things, really landmark expedition in terms of its thoroughness and scope, going all around the world, bringing back all these samples, still baselines for many studies that are done today. And there are multiple reasons for doing this. One of them was people were curious how deep the oceans were. And they got to not exactly to the deepest part of the ocean, but they've got 5 miles plus. In fact, when they got near the Mariana Trench, they ran out of rope. It was so deep. But they initially sounded and found very deep parts. Interestingly, there was another reason why they were doing this is in towards the end of the 19th century, they were very interested in laying cables for communication, for cables, for cabling, for all kinds of reasons to go across the ocean. And so they were curious about what that looked like. And here's what that looks like today to give you a sense of they were on the edge when cables were going in. This is what it looks like now. It looks like a complicated switchboard, but our commerce, our transactions, our communications, our internet, all these things go through these series of underwater cables. And you can see it's a very complex array. And that's one of the reasons why mapping the ocean and getting a better sense of the whole of what started is really so important. And you've probably heard ideas like maybe there's been only 20% explored to a certain resolution. The facts are we have some view of the whole ocean by soundings, et cetera, but the granularity that we have for Mars or the moon or most places on Earth, we're still only maybe 10 or 20% of the way there, but there's great momentum around that. So let's keep on going. We hit 1875. We plumbed the depths, but we couldn't certainly go there. Now we're going to go there. And we're going to go there 3 different ways. On the left is the Trieste, 1960. Jacques Piccard, Don Walsh, again, a Navy expedition, did go down to the Mariana Trench and went down the 6.8 miles all the way to the bottom. It took 5 hours to get there. They stayed 20 minutes. And part of the 20 minutes because they had a cracked portal, but a brave initiative about how they put that together. It's fascinating. But that, again, think of that as a sort of a Navy thing. At the same time, Sputnik had just come out. There's anxiety about America and its prowess and could we get into space? And so this was a big deal to demonstrate that we could go to the bottom of the ocean. It wasn't until 50 years later, in the middle there, that James Cameron went to the bottom a different way. He funded it through private means, himself and others. So it wasn't a governmental approach. He could go down, he could stay longer, he had better instrumentation. So this point about being the first to somewhere, you could say that Trieste was the first, and it truly was. But when James Cameron went down in Deep Sea Challenger all the way down there, he was seeing an entirely new landscape, an entirely new place. More recently, to the right, Victor Vescovo, starting a few years ago, took and expanded it, went down to the same place, but in a reusable container and taking multiple people down. So I believe now the answer is almost 20 people have been down to the Mariana Trench. So if you look at that arc of going to the bottom of the ocean, think of space. It's very similar. You started with the Cold War, sort of military funded. You have this transition to a sort of more public array and approach. And now more recently, the technology has gotten such that you can go up and down much more. There's incredible parallels with space in so many ways. There's a great visualization. Esri is going to pop up one more time. That's a group that does incredible geospatial mapping. This is a storyline from Mariana Trench to get a sense of how far down that is. And that little strip that you see in the middle, just as a teaser, is actually Manhattan. And if you start at the top of the map at the surface, that's the edge of Central Park. And then you walk all the way down to the bottom. And that's to give you a sense of how deep 7 miles really is. And it's okay if you can't read every single feature in there, but I encourage you to go visit the site. It's got great stuff on it. Alongside of the deep dive stuff, there's all kinds of other science going on. And in the 1840s and 50s, there was great mapping elements because they wanted to understand the trade winds, the doldrums, how things work. And so this was a map that was put together based on over 11,000 soundings taken from totally different places and pulling them together into one place. That is a great analogy for what's happening today. We've got so many scientists and explorers collecting information from all over, and there are efforts underway, and we have to redouble them to make sure that they speak the same language, so they can compare across different expeditions. But this is a visualization of what the trade winds look like, and that's a very detailed version in the 1850s. Today, of course, we have much more refined ways to do it. Sorry, I think it went too far again. No, I got one too far. There we are. So some of you being in Europe may be familiar with Copernicus, which is a satellite system of the EU, which has transformed observations on Earth and the ocean. So that map that we just saw about currents, this is a map that's based on satellites and high tech and all the things you would imagine. You can go if you haven't learned about Copernicus, I highly encourage you to go on the site. It's amazing in terms of pulling together all the information, the satellites, the models, and a series of visualizations that really help you understand the oceans, because it's so important. We talk about education and how important it is to be educated, but taking all those explorations and science and technology and distilling them into things like this is very important. Another example of that would be what NOAA has done. Oops, sorry. What NOAA has done in terms of models, and they basically pull together all these different observations, combine them with climate models, and then you can manipulate that and see different versions of climate change based on what your own personal expectations are. You can modify that and see what all of that looks like, so you can get a real sense of how the data pulls together. Very important work. And back to the point about just a bit on climate, because now we're transitioning to today and the future. There we go. Again, at the intersection of science, technology, and exploration, Spencer Glendon has done some very original work in this space with McKinsey, with the Woodwell Research Center, with others. And basically has now got an enterprise called Probable Futures that tries to bridge science and all of us that are not scientists. And to make this clear to the business community, where when you do financial models, if you have 5 years, that's good, but 10 years of data is good. 25 years of data is really good, but 100 years of data would be crazy. So we have 800,000 years of data on CO2. And this is all publicly available information. On the top, you see CO2 levels over 800,000 years. And again, exploration and science, these largely come from a set of ice corings from Antarctica. So again, that's at the intersection of those three disciplines. And on the bottom, you can see global temperature. So let's overlay those for a minute. And that's the correlation. So when you talk to people about climate change and, well, is it really does it really track the CO2 important? Of course, all important, but that's a pretty good correlation. And unfortunately, that X up in the right hand corner today in parts per million, which is well above the 300 level you see there, but over 400 now. So a couple of different ways now of pulling together research is being done, and touch on some of the big issues of the day. Plastics is clearly one of them. I'm sure you've been involved in hearing about different aspects of them, and everything from let's create new materials to let's capture it before it goes into the ocean to let's clean up once it gets into the ocean. And I think the common wisdom now is the phrase is no silver bullet. We have to do all those things if we're not going to have a lot more plastics in the oceans by 2050, as the MacArthur Foundation said, more plastics than fish in 2050. We have to tackle it. And what this map shows is as you map the plastic going to the ocean from the rivers, you can see the concentration of it, and therefore you'll see more and more activity. You already are of whether it's funds or scientists or research or initiatives to keep things out in those areas. Not that the whole world's not important, but the concentration is notable. And for a great report on plastics, by the way, I would refer you to the Pew Charitable Trust. Did great work on that. So let's change over to fishing for a moment. And there are a lot of different issues around fisheries and aquaculture. One is this idea that so many of our fisheries are close to capacity or fished out. There's illegal and underreported fishing, which is tragic in many ways. It steals from livelihoods. It's got grave human social consequences. So getting your arms around that, if people say, well, let's do policy and let's pull this together and let's enforce these things. Again, what you Global Fishing Watch, again, has a very robust site where you can go into a map and you can basically go across the world. You can track individual ships. You can look for boat activity. You can look at implied fishing activity based on different metrics, and it's too much to go into in detail here. But this actually is at night. And this is boat activity based on the light that's being emitted from those ships that's being tracked by satellites. So again, that's science for sure, because you have to know what you're looking for. It's technology for sure. It's the intersection of big data, if you will, and technology, the scientists who know what they're doing. And to me, that is the new edge of exploration, is pulling these things together so we can make better stewardship decisions about this planet and our oceans. Let's switch to coral reefs for a moment. So you may have heard of an initiative called 50 Reefs a couple of years back that went alongside the very successful movie Coral by Richard Vievers and a number of other people putting that film together. But they had the idea, if we wanted to conserve the 50, quote, most important reefs, in other words, they had a chance to survive, but they were important from a biomaterial perspective, important from a diversity perspective, coral diversity. Where would those be? So they did a year project where they got scientists from all over the world and all kinds of stakeholders, and they said, what are those 50? Interesting to see how what they call the coral triangle there, that bunching on the lower right, comes up again and again because of the incredible biodiversity there. And whether or not these are the right 50, the way I look at it is these things are all directionally correct. And let's get people out there doing this research, doing this work, but importantly, communicating back in ways that are understandable to people like you and me. Here's another way to look at this, and this is amazing work that is done by UC Santa Cruz that basically thinks about these are the reefs around Oahu, Hawaii, and the idea here is what reefs are worth more than $1 million, and the $1 million is defined as things coastal protection. It's very hard to sort of quantify this elements of what's going on around the coast, degradation. How do you value nature? And a lot of work is going on that. You may have heard more and more the phrase blue natural capital. And that's a very important part. And again, visualizing things like this so people can say, okay, this is why these are important. Because if we don't have coral reefs and mangroves and seagrasses, and we do have increased storms with increased severity, we're going to have big problems in terms of social justice, because people live near the coast who aren't necessarily in a position to afford to combat whether it's flooding or acidification of their oceans, any of these things. But having healthy coral reefs is a very important part of that. The question is, who's going to pay for education like this will help release more funding, whether it's from the private sector, from governments, from NGOs, from individuals, from investment institutions, to tackle these big, big questions of our day. Another way to look at marine environments, and you just have to go to the site to see this because it's remarkable. It's basically geospatial representation of environmental baselines. Emus, as they do. So I just did a screen grab here, but if you go on the Esri site, you can go and see what's the biodiversity within these, all kinds of different mappings that go along with these sectors of the ocean. They use very, very high-tech methodologies to get points to let them map this out. And now people who are planning things or trying to conserve coral reefs or thinking about where to build resorts, all those things, people can have access to much better information about what these environments look like. And this is a snapshot of the Maldives. But again, you can rotate this around. You can go to different places. I highly encourage you to take a look. And you can even follow sharks. So OSearch, you may have heard, is the one that has done over 400 shark taggings. Those are the sharks. You can follow them. It's enormously popular with school groups. And again, great white sharks in previous years have been thought of as predators and jaws and those sorts of things. But this sort of education with here's the sharks, here's where they're going, identify with them, pulling them, but doing the context. They work with scientists, and do your best, directionally correct, to take science, and that's certainly exploration, and pull that all together and better understand these magnificent animals. And their health is so important because they're an apex predator in the whole ocean system. Blue carbon is another thing you may have heard about. It's a popular topic, and the idea there is that whether it's seagrass or mangroves, or anything that's green in the ocean has carbon sequestration or trapping capabilities that's substantially in excess of what forest. And I've heard ranges anything from 5 to 20 times, but the facts are it's very effective. The blue there on this map from the Ocean Health Index shows you some of the places where blue carbon is trapped. There's a lot of work going on right now because this idea of like, well, if all these people want to be carbon neutral, shouldn't they be funding these mangroves? So a lot of people are working on that. There's some substantial issues you have to tackle. You have to be able to measure it accurately, which comes back to science. Is it actually being sequestered? How can you prove that? How can you show that? Is it measured? Is that an area that would have been protected or grown anyway? Is it truly additive to the system where you're helping with CO2 reduction? Or is it something that would have been done anyway? So it's a more developed market for forest and land, but it's vitally important for the oceans. Early days, but it's got the potential, as you can see, how it's distributed all across the globe to have huge impact. Again, CO2 being at the foundation of so many of the ocean's issues and challenges, whether it's warming, which leads to sea level rise, or acidification, or deoxygenation. All those things ultimately come back to greenhouse gases. Plastics, of course, are a version of carbon as well, but not quite in that CO2 category. So this is one you probably haven't seen before. So Harvard University started collecting data, geospatial data across the continent on all different kinds of things. And you may have seen a great article in the Washington Post a while back that took Roman roads and it mapped those onto light from space at night. And you could see the prosperity followed the Roman road system that was laid down thousands of years ago. It's just an amazing map. So this is the same system, but what we're tracking here is shipwrecks plotted against winds and tides. And the reason I call it citizen science is that all those little red dots are shipwrecks. And if you think about discovered, a lot of them were by scuba divers, where people go out, they find it, report it. It wasn't all scientific missions. And 2 points that I would make here: if you look to the right of Italy and you see this long spread of red dots, you say, well, why are so many there? Is there a bias because just more people dove there? Well, in fact, the industry there hasn't been as robust as some other places. But what did happen is for centuries, when people wanted to sail to Venice, they would hug the coast on shore, and that's why you have so many shipwrecks there. So that's a true artifact. Of sort of a different version of artifact is on the lower right in Turkey. you can see a little clump of red, and you say, wow, why so many shipwrecks right there? Well, it's because when George Bass and others basically founded the modern art and science of underwater archaeology, that's where they set up camp. So they found kinds of stuff all around there because they were looking for it. So that's a very different story than the map showing that here's all the people navigating up the coast of Venice. That actually is a man-made, citizen science-driven piece where you have all the shipwrecks discovered because that's where the people were. And I'm going to give a brand new example, which is Fabien Cousteau just mapped with using pretty high-tech means an MPA, a marine protected area off the coast of Curacao. And I'll tell you in a minute while he's doing that. To the right, you can see it's so new. He just literally finished that they haven't had time to consolidate all the information and show you the wonderful maps of what this marine protected area looks like, which again fits back into all these other things that we've talked about over time with more data, but putting it into usable ways in repositories that people can access and using metrics that people can actually understand. So he is continuing to his father's steps, literally in his grandfather's steps, to plot the ocean and to understand it better. And to the right there is an example of what the technology is, credited below there. But these are Army tanks that were sunk off of Florida, and you can see the resolution that you can get. So why is Fabien doing this mapping in Curacao in particular? As you may have seen, he's got a vision for a whole new world of underwater exploration. It's called Proteus, and it's a giant project, much bigger scale than what's happened before. And if you think back to the trajectory, back to the question about the Cold War and man in space, or people in space, people under the ocean. In the 1970s, there were over 70 underwater habitats, working habitats all around the globe. And today there are one, maybe two, depending how you count them. One's off Florida, one's in Asia. So we've come a long way in sort of not going down there again, and not unlike the Trieste, with a big gap to Cameron. Here's a version of going under the sea. So is it exploration? Yes, you can see the little diver there, so it must be exploration of the submarines and underwater, the habitat that would be built off the coast of Curacao. Is it technology? Absolutely. If you look at the design of that station, that habitat, it is all kinds of different things pulling together in terms of designers, scientists, etc. And of course, there's a huge chunk of science because that's one of the reasons to go down there is to explore more. And so I think it's a nice endpoint for us to pull together this idea of there's so much more to explore, but here's a way to think about future exploration with purpose. So the days of going to the South Pole, the North Pole, outer space, there's always that excitement about the first. And by the way, there still is, because there are plenty of places we haven't been, places in the deep ocean, places in space, caves, deepest parts of jungles. There will still be firsts. But at the same time, urge and sense of necessity to explore with purpose and to bring back knowledge that we've found out in the space. Whether you're part of the Explorers Club in New York City, where where I'm a member and I'm such a fan of all the things that they're doing there. But it could be scientific institutions, it could be citizen science. I think there's more and more of this urge to get out there and explore, but really do something about it to tackle those issues that we talked about earlier. So I'm just at my end of my talk here, and I hope I've given you a little sense of how these different pieces tie together, exploration, science, and technology. Hopefully pointed you towards a few fun things that will drag you onto the internet and give you, if you want, hours and hours learning about the oceans as such an important and precious resource for all of us to make sure that we steward effectively into the future. And it ties back to that issue of we're in the ocean decade. We've got increasing awareness of the tenuous place we're in with respect to climate, and climate is inextricably twinned with oceans. So it's important that we on these things. So I hope you enjoyed the talk. I thank you so much for your attention, and I'm happy to continue the dialogue with anyone who wants to look me up. Thank you so much for letting me be here.